Good morning, everyone. My name is Ramyashri, and I'm an MSc Data Science student. This is my ID card, and I will be presenting my research title Developing an Explainable AI Framework for Renewable Energy Grid Optimization, Addressing Bias, Carbon Footprint, and Governance Challenges. In the next 5 minutes, I will explain the research problem, objectives, methods, key findings from the literature, and ethical considerations. The research problem and aim. The global shift to renewable energy is a major challenge. As solar and wind energy increase, ML is used more for forecasting and optimization. However, the most accurate models like deep learning and ML layers are often black boxes and hard to understand. This is a problem because energy system require transparency. Regulations such as EU AI Act, GDPR, and OFGEM guidance requires AI systems to be explainable and monitored by humans. So the aim of the research is to design and evaluate explainable AI framework that balances accuracy framework, carbon impact, and regulatory compliances. Research objectives. This aim is divided in five objectives. First, review existing XAI methods in energy system and analyze the trade-off between accuracy and interpretability. Second, build three ML models: random forest, XGBoost, and LSTM. Third, compare the three models that are built: SHAP, line, and salience technique using standard metrics. Fourth, perform a bias audit across different regions using fairness tools. And finally, measure the carbon footprint for training using the code carbon methodology and design. This system uses design science research as it focuses on creating a working framework. The epistemology follows a pragmatic approach combining numerical evaluation such as accuracy, fairness, emissions with human understanding of explanations. Data will come from three sources: NREL, OpenAI, ENTSOE, and the UK National Grid, giving around 500,000 records from 2019 to 2024. All the models will use the same data splits and be tuned with Optuna. Explanations will be tested using metrics and feedbacks from expert systems using system causability scale. Literature review. The literature shows a clear research gap. A major review found that most studies use SHAP and focuses on forecasting. However, no study combines all five areas: multiple models, XAI comparison, bias analysis, carbon tracking, and regulatory focus. Some studies cover some parts of it, but none integrates all. This gap is important because new regulation requires explainable and fair AI systems in energy. LSEPI, legal, social, ethical, and professional issues are built into the research. Legally, the framework follows GDPR, EUAI Act, and OFGEM guidelines. Socially, it considers energy fairness across regions. Ethically, it measures and reports the carbon impact of AI use. Professionally, it follows ACM and BCS standards with transparent reporting and open source code. Project plan and risk. This research is currently at a proposal stage developed between February and March 2026. The full project is planned for later implementation. The two more critical risks are dataset inaccessibility and XAI fidelity trade off. Both are addressed to architectural redundancy. Threes, these three open access data sources with GAN based synthetic augmentation as a fallback. And by adopting post hoc explanation methods that decouple the explanation layer from the model, preserving the freedom to use high performing black box models while still generating interpretable outputs. In conclusion, the research provides a structural and practical XAI framework. It contributes both academically and practically by combining technical performance and also ethical with regulatory needs. Thank you.